All right, I assume you've read and done the problem, and this is the infamous potato problem. This was given in 2017, and it was the worst students have done on a problem in decades. So we need to go over it because it's really not a hard question. Just a lot of people did not read it correctly or interpret it correctly. Okay, so we got the internal temperature of potato. It's measured by dHdt. Now, keep in mind, because this is very, very key for the whole problem. Normally, we have dy dx. H is my dependent variable. It's like my y in this problem. So keep that in mind. That's like a y. That's not your independent variable. It's your dependent variable. Okay. So part A, write an equation for the tangent line at t equals 0. Use it to approximate the internal temperature at time t equals 3. Okay, so let's right away. So if t is 0, that doesn't mean h is 0. Okay, t is 0, h is 91. So I'm going to evaluate dh dt when t is 0. That'll give me negative 1/4 91 minus 27. And that gives me negative 16. So there's my slope. Now I need a point. Okay, so my point is 0 because my independent is t. And 91 is my dependent. So I have y minus 91 equals negative 16 t minus 0. So y is negative 16 t plus 91. Now that's part of the question. Now it says use to approximate when t is 3. So y of 3. Plug in 3, you get 43 degrees Celsius. Part A was worth 3 points. One for getting the slope, one for the tangent line, one for your estimate. Okay, part B, find the second derivative. Determine if your answer in part A is an over or under estimate. Now, remember, the second derivative tells us that because if we are concave up, that tangent line is going to be below. If we're concave down, that tangent line is going to be above. Okay, so let's find our second derivative. This is where a lot of people messed up. So d squared h dt squared is negative 1/4 h prime, right? You have to use implicit differentiation. H is like your y. So whenever you take its derivative, you're going to have to multiply by h prime. Now, h prime we already know is actually all of that. So you have negative 1/4 h minus 27 when we plug in for h prime. Clean that up just a tad. Just going to make that 1/16 h minus 27. I'm not going to distribute it because here's this random information. You're like, what the heck are we using that for? The temperature is always greater than 27, which means this part is always positive. So my second derivative is a positive number. So if its second derivative is positive, that means we're concave up. Let me try to write that. And if you're concave up, that tangent line is going to be below the curve. So that means it's an underestimate. And that part was worth, oh man, only 1 point. That's kind of crazy to me. Only 1 point. Okay. Part C, okay, you've got an alternative model, satisfies that differential equation. Find expression for g. So basically, you want to go backwards. Now remember, g is like your y. That's like your y. So we're going to do a little separation of variable on this. Okay, I'm going to go to a new page for that. So we have, let's see, dg dt was negative g minus 27 to the 2/3. Okay, so we're just going to take that over. I'm going to leave the negative over there. So I have 1 over g minus 27 to the 2/3 dg negative 1 dt. Okay. Now remember, that's a little substitution problem. That's g minus 27 to the negative 2/3. Do a little substitution. We don't really need to because the derivative on the inside is 1. So when I do that, whoops, add 1 to the power and divide by it. But I skipped my substitution there. You go ahead and show it if you need to. I have negative t plus c. Don't forget your c there. Now let's start working our way to solving for g. So divide by 3. Now c divided by 3 is still c. Add 27. Oops, sorry, I dropped my 1/3. Let's do that over again then. Okay, so we'll cube both sides. I'm going to go ahead and write this c minus 1/3 t cubed. Add 27. Now I need my initial condition. Let's see, they tell me g of 0 is 91. So plug in 91. And t is 0, I get c cubed plus 27. Subtract 27. I get 64 equals c cubed, so c equals 4. Plug it back in. So I have 4 minus 1/3 t quantity cubed plus 27. Okay, now it says use that to approximate the time at t equals 3. So when I plug in 3, it's just good old plug and chug, we end up getting 54 degrees Celsius. Part C was worth 5 points. Like I said before, they have not had this many zeros on a problem in years and years. So keep in mind, this was 2017. So we might be due for a similar problem because people didn't do so well. They want to see how well people adapt and learn. So keep that in mind. Study this problem for sure.